Imagine you're driving home after a long day. The road is smooth, your speed is steady, and everything feels completely under control. In this moment, you feel like you're sitting still, but beneath your tires, the ground is moving with a velocity that your senses aren't built to detect. This chart shows how fast the Earth is actually rotating. At the equator, you're traveling at nearly 1,000 miles per hour. Even in cities like New York or Dallas, you are moving at hundreds of miles per hour simply by standing on the pavement. Our everyday experience of being stationary is a byproduct of being part of a massive, continuous system of kinetic energy. We don't feel this 1,000-mile-per-hour spin because of shared relative velocity. Because everything around you is moving at the exact same rate, there is no physical sensation of speed. It's the same physics that allow you to walk down the aisle of a passenger jet cruising at 500 miles per hour. As long as the plane's speed remains constant, your body feels as if it's in a living room on solid ground. But the comfort of that flight relies entirely on one condition: the plane cannot stop instantly. Our existence on this planet is predicated on this shared momentum never being interrupted by a sudden, catastrophic halt. If the Earth's bedrock were to stop dead in its tracks, with no gradual deceleration, the results would be immediate. This is Newton's law of inertia. When deprived of its path, everything not bolted to the core continues at its original speed. The crust stops, but unanchored cars, buildings, and people are violently launched on their eastward journey. Near the equator, that means you are suddenly traveling sideways at nearly 1,000 miles per hour, well beyond the speed of sound. The momentum we never notice in daily life is instantly transformed into a force that turns every loose object into a supersonic projectile. Human infrastructure is designed to withstand vertical loads and wind, not a sudden, massive transfer of horizontal kinetic energy. Modern skyscrapers undergo impossible lateral stress. Their steel skeletons buckle in a fraction of a second, while every pane of glass shatters and sprays outward at hundreds of miles per hour. Engineering marvels fail just as quickly. Concrete highways are cleared of traffic as vehicles launch from the asphalt, and steel bridges twist into scrap. In an instant, entire cities are converted into clouds of flying concrete, steel, and glass shrapnel, moving too fast for the human eye to track. There are no sirens. There are no emergency alerts. There is simply no time for a biological system to react. A single moment of normalcy is followed by the total mechanical failure of the built world, leveled by its own retained speed. While the destruction on the ground is total, it is only the beginning of the event. The bedrock has stopped, but the Earth's fluid elements, the atmosphere and the oceans, have not. They still possess their 1,000-mile-per-hour eastward momentum. The resulting atmospheric disaster is absolute. Supersonic winds scour the continents, stripping the remaining soil from the stationary crust. The oceans follow suit. Water is thrown from its basins, creating global tsunamis that sweep across entire continents in minutes. For anyone who might have survived the initial collapse of their surroundings, the true threat is now closing in from the horizon. Our safety is the result of a delicate, ongoing balance of motion. If that balance is lost, the catastrophe arrives not just from the ground beneath us, but from the very air and sea around us.